Right, hey there. Today I'm talking about polymers in guitar. And you may be thinking that guitar is mainly made of wood, which is a natural polymer, but there's more to that. Come check it out. Right, before I start, I need to talk about what polymer is. Polymers are long-chain, huge molecules that are made of small repeated units called monomers. These monomers are usually joined by condensation or reaction to join a really long chain, and these have really wide use in our real life. Synthetic polymers are usually rubbers and plastics, and in nature, DNA is also a polymer that's made in our body. And today I'm going to talk about polymers that are applied on guitars. In acoustic guitars, there is a polymers called lacquer that apply on the wooden body of the guitar. As we can see, we got lacquer here, a lacquer on the head of the guitar, also on the neck of the guitar as well. Lacquer is made of a main component called nitrocellulose that are dissolved in a volatile polar solvent such as acetone. When you apply the lacquer on the guitar, the solvent will evaporate and leave the nitrocellulose bind with the wooden body and gives that protection to the wood and the glossy feel of the guitar. Well, cellulose has been used as replacement for ivory in the past, but it has also been banned due to the flammable and explosive properties of nitrocellulose. So nowadays it has been used to make table tennis balls or even guitar picks. Lacquer blinds on the wooden parts on the guitar quite well because they are quite similar structure, but as a disadvantage of lacquer is it's quite flammable. Also, it wears off over time because lacquer is made of cellulose, which is a natural resource. And by applying lacquer, it does not seal the entire wood of the guitar itself. So musicians say the wood can breathe out the guitar. And some musicians argue it's better to not apply anything on guitar because the wood on the guitar can age, but somebody don't. Cellulose is a natural polymer that is made from a sugar molecule called beta-glucose. These monosaccharides join together by rotating themselves equatorially via condensation reaction, forming a 1,4 glycosidic bond between the monomers. These polymer chains are held by hydrogen bonds to form a strong cell wall within the plant. Nitrocellulose is made by nitrating the alkyl groups on the cellulose chain via electrophilic substitution. Here is the overall reaction, where nitric acid reacts with cellulose by using sulfuric acid as a catalyst. Please note that this is the reaction of nitrating one beta-glucose molecule on the cellulose chain, as one beta-glucose has 3 alkyl groups. The first step of the reaction is to mix nitric acid with sulfuric acid to form a nitrating mixture, where nitric acid acts as a base to take a proton from sulfuric acid, forming an unstable intermediate which will be quickly decomposed into water and nitrogen ion, a very strong electrophile. The nitrogen ion can then be attacked by the lone pair on the oxygen of the OH group on the cellulose and form an intermediate like this. The conjugate base forming previously in the nitrating mixture will then take the proton on the OH group. Then the bonding electrons will move back into the positively charged oxygen, forming this nitrating cellulose and regenerate sulfuric acid. Here is the structure of fully nitrated cellulose polymers, which is also called gun cotton. It's really unstable because the NO3 groups want to convert back to nitrogen gas. Therefore, the higher the nitrogen content in the polymers, the more explosive it is. Is nitrocellulose the only polymers that apply on guitar? Of course not. In electric guitar, there are plastic coatings and plastic parts that are made out of a synthetic polymers called polyurethane. Polyurethane is a hydrocarbon. As you can see, looks completely plastics. Also, these plastic parts are all made from polyurethane. The advantage of polyurethane, unlike nitrocellulose, is it's not flammable and it's quite water resistant. And it also seals the entire wooden body of the guitar completely, and some musicians argue that it will not age the wood of the guitar and cannot improve the tone of the guitar overall. Polyurethane is formed by using methylene diphenyl diisocyanate, or MDI in short, ethane 1,2-diol with triethylene diamine, a bidentate ligand which also called TEDA as a catalyst. In the first step of reaction, DETA acts as a base to take a proton on one of the OH group on the diol, giving a strong negative charge on the oxygen which can attack the carbon on one of the isocyanate group on MDI, forming an intermediate like this. Then the pi bond will take back the proton from the protonated DETA, and the negative charge on the oxygen will push back into the sigma bond to form a double bond. The result is a linkage like a mixture of peptide bonds found in protein and ester bonds, which is called urethane bond, and hence the name polyurethane. Right, what about strings? Other than metal strings, nylon strings are quite common among acoustic guitars. Nylon is a polyamide that is flexible and strong and can be used in clothing fibers. Also, in metal strings, there are also coated metal strings with a special fluoropolymers to protect it from damage from your hands, such as corrosions. Right, wood is not the only material that has been used to make guitar nowadays. Synthetic polymers such as acrylic hydrocarbons or even carbon fibers are also being used to make guitars. The advantage of using these materials to make guitars is it can be molded into a single piece of body for the guitar, instead of where wooden guitar we need to stick two pieces together, the neck and the body together, to make one single guitar. Therefore it can prevent the weak point from the neck and the body when you use a single piece of guitar body. Also, you can also form more different types of shapes of guitar by using 3D printing technology as well. However, these materials are still quite expensive, especially for carbon fiber, and not everyone prefer the sounds of using these polymers for guitars, as they vibrate in different frequencies, and so they will have a different tone. Right, that's all my time for now. Thank you for listening to my video. Hope you have a better insight for polymers in guitar. I'll see you later.